Yeah, so this is a really interesting deep dive. We're going to be talking about how you can use Dagster and Modal together. I'm going to be co-presenting with Charles. My background, I'm a developer advocate here at Dagster Labs with a background in data engineering.
Hello everyone. I'm Charles. I am. My title doesn't actually have extraordinaire in it. That was Colton being very nice. I'm an AI engineer at Modal. I use the infrastructure platform that we've built to build cool, AI systems from a social media full of bots pretending it's 1995 to a satellite data ETL pipeline. And today we'll be talking about how, speaking of pipelines, modal infrastructure works great with Dagster orchestration to accelerate your ML workflows.
Nice. Yeah, so let's talk about the overview. So machine learning workloads often require unique infrastructure. A lot of times they need GPUs. And Modal offers a scalable infrastructure that you can define in your code. And it happens to work really well with Dagster. So Dagster is really strong in managing state of your pipelines through the full end-to-end data ingestion, data transformation, loading into a data warehouse. And it can really leverage the Modal scalable infrastructure to be able to use GPUs and just like scaling out compute to have a more robust set of infrastructure at your fingertips. So it turns out Modal and Dagster, like the developer experience between the two, really go well together. Do you have anything to say here, Charles? Or should I go to the next one?
All I'd say is, turns out we both love decorators as much as we love really good developer experience for ML teams.
Yeah, that's very true. Cool. So the strengths of Dagster. With Dagster, as you may know, you get the full data lineage. Some of your assets may use Modal, some may use OpenAI. That's the case here in this demo. But Dagster can maintain that context through the full pipeline. And you can do really cool things with that in like having partitions for your assets. So say you have an asset that needs to materialize each day and you have it daily partitioned and you have a pipeline that you want to run daily, you can pass in that partition context to those individual assets. And when you're running something like Modal, you can pass in that context to the sub process. And we'll be showing you how to do that using Dagster pipes later on. And then also through Dagster, you get more resiliency and observability of your assets. So we have checks and alerts and retries, and you can really build robust pipelines. Yep. And then Modal.
Yeah. So if Dagster's helping you create a pipeline by like combining things together without losing track of it, with observability and alerting, Modal is really great at providing those pipeline components. Modal, we call it a self-provisioning runtime. You write in the middle of your code like what you will need when you're going to run, whether that's 100 CPUs or 100 CPU machines at once or 10 GPUs at once or networking, and you get it once you modal run your script. And we get that without sacrificing the like good developer experience you're used to from developing locally. We rebuilt like a whole container stack from the like file system to the container runtime, in Rust and with good defaults or different behaviors and engineering decisions for data-centric, computation-heavy workloads. And the outcome of that is you can get the sort of auto-scaling distributed apps that teams at some of the like most advanced hyperscalers are able to build based on internal infrastructure. You get all of that, but without all the like agonizing pain of writing a bunch of Kubernetes YAML and learning how GPU operators work or whatever. And then finally, because it's self-provisioning and serverless. So you might say, oh yeah, I want a GPU to run this step. I want to use a language model to like enrich customer conversations. But you don't want to have a GPU all the time. You only want it when you're running that workload. So we get you GPUs within seconds. We charge you by the second, as opposed to requiring like a 18-month reservation for at least 100 H100s. You can get an NVIDIA H100 GPU for 5 seconds and then let go.
Yeah, and I don't think we can stress enough like how good the developer experience is of Modal. I know I was really blown away when I used it for the first time. You just add a decorator to your Python function, and then next thing you know, it's running remote just in seconds. Like it spools up the container, installs your dependencies and everything. It's just so blazingly fast. It's really impressive.
Thanks. Yeah, so to double click on that, These are some sample modal functions from one of the first demos I made for modal, actually, when I was still just a user. Stable diffusion models had just come out and people figured out how to fine-tune them. So I fine-tuned them on my roommate's dog, QWERTY. And so now I had a QWERTY art generator. That's QWERTY in Morrowind, same video game series as Skyrim. And in order to build this application, I needed to fine-tune on GPUs, and then I needed to serve a UI. That's a UI in Python using the Gradio library. And to do that in Modal, all you need to do is take a Python function that can train a model, a Python function that can serve a local fast API or Gradio app, and then decorate it. So there's two decorators, app.function on those, actually three decorators, app.function, that's sort of describing a lot of like compute and storage infrastructure. Colton mentioned like dependencies. That's the image line at the very top of those decorators. You can see GPUs, remote storage, all that's in there. And then the modal.asgi app decorator highlighted at the bottom. That's like, okay, this is an asynchronous server gateway interface compatible, like fast API style Python app. Please like spin me up a URL and deploy this. And so all in a single Python file that you can do modal run and modal deploy, like you get from this example of like fine tune a model and serve it in production with autoscaling and everything. So this is the sort of thing that for that training run in that example, I'm not using Dagster to orchestrate any of my pipelines. So I just have to make sure to have good discipline, and it's only a short pipeline, so I don't have to worry about it that much. But I have these like useful components, and I need something to kind of combine them together.
That's right. Yeah, so stronger together. In building this demo and collaborating with Charles, it became really clear that Dagster and Modal work well together. You can do the quick prototyping with Modal, and then when you want to make it production ready, it's very easy to then like wrap that in Dagster and make a very robust pipeline from it. So some of the strengths, they're both developer friendly with an effort on making a good local developer experience. They're both cloud native. Sorry. Yeah, we have the cloud native orchestration on top of a cloud native infrastructure tool. And finally, I think one of the things that it allows you to do is you can focus on your work and not your infrastructure. So Dagster is kind of like giving you this framework for building your pipelines, and Modal's giving you the infrastructure, and you can just work on solving your problems. And the difficult things like managing the infrastructure are kind of in the background. You don't have to deal too much with that technicality. So what are we doing in this demo? I'll let you talk to this slide, but at a high level, we're going to be summarizing some podcasts.
Yeah, so podcasts. There's like a couple hours of yapping in them. There's like a lot of content. Usually, there's a lot of podcasts. There's more than 24 hours of podcasts released a day that I would maybe be interested in, and that's kind of a bummer. They're not easily searchable. I would love to have like a quick summary, so that instead of like listening to a former like boxer in a basement for 3 hours, I can just get that he asked somebody whether they believe in aliens and they said no, which sounds reasonable to me. And that saves you like a couple hours. So the pipeline that we put together takes in podcasts and turns them into email summaries.
Yeah, exactly. So the way this is going to work is we have a pipeline for each podcast. We'll show the architecture, and later on, we're actually going to be digging into the code and just talking through the code together. But at a high level, we are subscribing to an RSS feed with podcasts. We're getting the MP3 file. And then finally, like the resulting product of this is that you'll get a summary of the podcast in your email. And depending on how frequently you run things, it'll be for a podcast like as soon as it's released. So here's a high-level architecture of what we'll be doing. Somebody asked, will the summary generated of this episode also be sent by email? Yeah, that's a good point. Yeah, we can summarize this too. So at a high level, the architecture, we are subscribing to these RSS feeds. Before Spotify managed all the podcasts and like Apple Podcasts, typically you would have like an RSS like podcast subscription app, and you would subscribe to all these RSS feeds to stay up to date on the podcasts that you want to listen to. So we're going old school, and we're subscribing to these RSS feeds to get MP3 files that will throw in an R2 bucket. R2 is like Cloudflare's S3, and it's actually compatible with the S3 specification. So you can still use like the Python Boto3 library to interface with the bucket, and you'll see that in our code here shortly. Um, we'll be transcribing that podcast using the Whisper model on Modal. And this part's super cool in that it'll chunk up the podcast into little segments and then fan out the compute to run like hundreds of containers all at once. And Charles will be able to dig into that, but it's super impressive. And then finally, we'll be calling out to ChatGPT, OpenAI through a Dagster asset and summarize that and then send it as an email. So all the code for this demo resides in this repo here. So Dagster.io, Dagster Modal demo. You're welcome to fork it and run it yourself. If you have any feedback or questions on it, you're welcome to open an issue on the repo too. And if you want to just open it up and follow along in the code base, you can do that. But we'll be digging into the code here shortly. When you look at that repo, this is the high-level structure of the project. So we have our Dagster project, which is named Dagster Modal Demo. We have our Modal project, which is appropriately named Modal project. And then we have some of the accompanying files that are typically with a Dagster project. So we have like a make file so that you can just like run make dev or make install and things like that. Within the Dagster Modal Demo project, we have the like bare bones Dagster modal integration. So we'll talk about that, but we've implemented a Dagster pipes client to interface with the modal subprocess. And that's how we're calling out and running our modal project. For this project, we're actually using a pipeline factory. So instead of just having all of our logic in one big asset, we're using this factory method where each podcast will have its own pipeline. And when you look in the Dagster UI, you'll see the lineage for each podcast. We have the main modal script that we're running is this transcribe.py, and that's the script that's cutting up the segments of the podcast and then transcribing those. Anything you want to say here, Charles?
No, I'm looking forward to digging into this more.
Cool, sounds good. All right, at a high level, I wanted to talk a little bit about using a pipeline factory, and also we're using Dagster sensors. You might be familiar with these concepts already in Dagster, but I wanted to give a high-level overview before we dig into the code. So as I said, a pipeline will be created for each RSS feed, and each pipeline will have its own sensor. And this sensor is going to perform an HTTP request to the RSS feed and get the latest episodes. And RSS feeds actually have this concept of something called an E tag. And that's like a string that you can then send in your subsequent requests so that you only get the new episodes. So we're using sensors and we're maintaining a cursor on that sensor with this E tag. So the first time it pulls, it'll get all the podcasts. The second time, it'll use that cursor, it'll pull it again, and only get the new episodes. And that's how we're able to be more efficient in how we're downloading these podcasts and only getting the new entries. When there is a new entry found, that's when we trigger a run request to materialize our assets. So that's when it'll trigger the full download of the audio, transcribe it, summarize it, and email it.
Great. So Colton, like, I think you suggested that it was a good idea to kind of like have this pipeline factory, separate pipeline for each RSS feed so that you get like distinct lineage. Is that like the primary reason? Are there any other benefits to this like pipeline factory approach? Is it like code cleanliness and simplicity, or is it like robustness and extensibility? What are the benefits?
Yeah, it's a good question. For me, I liked this factory method in that I didn't have to repeat myself, and I was able to get these separate lineages that I could see in the UI and then go and easily like trigger a rerun or a materialization of specific assets. So having that like kind of separation is nice. I do think there are like multiple ways that this could have been implemented. For example, in Dagster, you can have multi-dimensional partitions. So we could have had an asset partitioned by the podcast and then partitioned by the episode. But for me personally, I just found it nice to be able to not repeat myself, have this function that generates my pipelines, and then be able to see everything separately in the UI in their own distinct paths.
Got it. And then the E tag is interesting. That's like a feature of podcast RSS feeds, like some open standard, I guess. And it says
Yeah.
like if you bring back your E tag, we'll only give you new podcasts.
Yeah, exactly. Yeah,
Okay.
so we're using a Python library to handle interfacing with these RSS feeds. So I didn't have to go and like reinvent the wheel on how to like pass in these E tags, but it
Right.
supports two ways. You can either use this E tag or the last modified date. And it said some RSS feeds support one or the other or both. So it's kind of tricky in making sure all the RSS feeds work. But yeah,
Mhm.
exactly. It's how you can only get the most recent episodes.
Got it. And so the concept of a Dagster cursor is just like some kind of state that you need to maintain in order to like interface with some external thing, like
Yeah.
like like the cursor that you have like when interacting with the database. But in this case, the cursor is kind of just this like string that never changes, and the state's really like actually being maintained on the other end.
Yeah, exactly. Though
Neat.
when you pull the RSS feed and there is a new episode, you'll get a new E tag, and then you can update that cursor.
Oh, okay, okay, got it. I misunderstood. I thought that was like server was responsible for maintaining.
Nope. Yeah,
Okay,
so we're
cool.
keeping track of it. Like another example where I used sensors recently was pulling a GitHub repo, and I would get the
Mhm,
latest commit, and that's how and then I would store that on the cursor. And then
mhm.
next time I would pull that GitHub repo, I'd be like, oh, has there been any more commits since this one that I have? And that's how I would know there are changes.
Got it. Neat.
Um, so you don't have to read this slide really, but this is just an example of what the RSS feed is. So here's an example of Dan Carlin's hardcore history. And a lot of times when you go to a website, you just put /RSS or /Atom. And a lot of websites have RSS feeds built in. But this is an example of the response where it's just a ton of metadata in the XML format. So you can see we have this channel tag with like an iTunes summary, like a title, a description, a link to it, a publication date. And then further down at the bottom, you can see there's this item entry, and you'll get like a list of items, and that's like each episode of the podcast. So just for your awareness, this is kind of like what we're dealing with under the hood when we're querying these RSS feeds. And here's what we'll end up with in the Dagster UI. So here are two of the pipelines. We have our Comedy Bang Bang podcast and the Practical AI podcast. And you can see we have 4 assets for each one. And we have these kinds tags attached to them. So you can see when we're downloading the audio in this audio asset on the far left, we have this Python icon. And then for our transcription, we have this nice little modal icon. So they very easily know that when we're using like this modal pipes client, then we're going to summarize it with OpenAI, and then we're going to be back to Python to send this email summary. And you can see there's right for this in this screenshot, there's like one partition, and the top one is currently materializing that partition. And these are partitioned by episode. So each time we get a new podcast episode, it'll be sent as a run request with that partition to the asset.
And so this is a case where you just got one episode from each of these podcasts. But I imagine the first time you ran it, it was like maybe tens or hundreds of partitions.
Yeah, so I've set a limit so that like we only go back 3, so that I'm not just using up all the compute. But yeah, it is possible the first time you run it, you would go back and get 100 podcasts and really use a lot of infrastructure compute. And I just wanted to highlight here also Dagster's metadata. So we're using the Dagster OpenAI integration to do the summarization. And it's really cool in that we can get like the tokens used. And we also have added the summary as metadata as well. So you can see here we have our partition. We have the timestamp that it ran. We have the summary that we put on the asset so you can just see it here in the Dagster UI. We have the summary key, which is actually like the object key in cloud storage. And then we have some OpenAI details. So we can see that it used 9,400 tokens in this instance. And it kind of gives you good insight into what's going on with your assets. And you can compare between your different podcasts or the different episodes and kind of see what's going on. I also wanted to give a quick overview of pipes before we dig into the code. So as I mentioned, we're using a pipes client to call out to Modal. And pipes is like a wrapper around sub-processes. It can both be like a sub-process just running on a local machine or a remote execution environment, but it allows you to easily handle the context that is being leveraged by these external processes. So in this case, Modal is running in a sub-process, but we want to access Dagster information from that. So we're able to pass in environment variables. We're able to pass in the Dagster context itself so we can get the partition key. And then the really cool thing is from these external processes, you can then emit events back to Dagster. So if a materialization occurs in this process, you can send those materialization results back. You can also send structured logs back. And some other popular use cases of pipes is like Databricks or Spark, where you have a different compute environment that you want to leverage, but you still want to be able to have the like reference of the Dagster context there, and you want to like get that metadata back into Dagster. So I think pipes was a really good fit for Modal in that it's like a different execution environment that we want to leverage from Dagster, but we still want to be able to send that information back. Cool. This one's for you, Charles.
Yeah. So yeah, we've seen a little bit of what Dagster was bringing. So from the modal side, um, couple pieces. One is you need to define the like execution environment, the container image for the workers that are going to be transcribing these podcasts. So we have this nice kind of like Pythonic interface to building container images. I don't know how much you've had to write like Docker files, but there's like a lot of footguns, like forgetting to include dash y or dash dash yes, that in the when you're doing apt install, and then you like don't install the thing because it's intended for interactive use. So we have like in our like Pythonic in the like SDK wrapping the Docker file builds, we've like included all those things, like yeah, with pip install. Yeah, so up here we're starting from like a very lightweight Linux distribution, Debian Slim, and then installing all the things that are needed, systems libraries and Python libraries. So Modal is like OCI compliant or the like open container standard compliant, but not actually using Docker under the hood. We had to rewrite that to be faster. Um, so you can bring your own Docker files if you prefer. If you have an existing pipeline in a Docker file, you can directly do Docker file commands, etc. But here we're just using the like higher level SDK. And then yeah, we're adding some decorators to get additional hardware. In this case, like GPU acceleration wasn't necessary. Turns like the Whisper models are small relative to current standards for models, and can actually run pretty fast on a CPU. So that's actually an important you know thing to keep in mind. It's like easy to reach for GPUs when it maybe gives you like better latency, but if you look at the like throughput per dollar, then it turns out to be a worse choice than CPUs. So Modal's not just GPUs, and it also makes it easy to like scale up onto like large numbers of CPU containers. So we like in this case we're running on I think probably low maybe 100 separate CPU containers. So the like overall plan of attack in this code is to read audio from R2. That happens in like a modal auto scaling function. So that will scale up. If you had like hundreds of files to read, you might get 100 separate replicas running at once doing that, and then and like chunk the audio up and then fan out over segments as well. So then within each file, we then fan out again to say like, okay, transcribe this segment, transcribe this segment. So in any case, basically the thing that works like super well, buttery smooth with Modal right now is to do embarrassingly parallel work. And in a lot of like analytics workloads, machine learning, a lot of AI workloads, there just is a lot of inherent embarrassing parallelism. It's something that only makes sense at large scale where you need a lot of data, and there's some notion of a batch or a chunk over which you can parallelize, possibly nested. And so that's the workflow that we've got a bunch of like high level, like both primitives and high level structures that we'll see for just like doing that transparently. And then that all gets uploaded back to R2 at the end. Oh, and I should say, like, since I always forget this. Sorry, I'm a like ML and GPUs guy. I like spent a lot of time with neural networks, so that's what I see. But there's also the cloud bucket mount. So the Modal has a notion of like remote storage in the form of volumes, and those can either be like you can use our like remote storage system, or you can bring your own buckets from like S3 and R2. So that's in that you'll see the volumes keyword argument in those two function decorators in the bottom right. Those volumes are external like R2 bucket mounts. Then okay, how does question in the chat? How does Modal handle failures at the segment level of retries? In this case, there is a notion of retrying in Modal if you want to do that. I think that's not a feature that gets a ton of love. I think like it works well for like simple things where you're like hitting an external API and you just want to like retry a couple of times. Um, People tend to implement the retry either like at a lower level, like inside of a modal function, or at a higher level with something like Dagster. But so you kind of have all three options. Um, then there is some like transparent to you retrying underneath because like we're running a big complex distributed system and that system has like random weird failures. So when we can do retries like that, don't invalidate the assumptions of your application, we do those retries. So it's like more robust. But yeah, you defense in depth, the end-to-end argument in systems design. You probably need it like at each end-to-end component. Another question, is GCS supported? Yeah, the cloud bucket mount feature right now is S3, R2, S3 compatible, and GCS. I can't remember whether they also have Azure Blob Storage included in there. But yeah, if there's anything that's not supported, let us know.
Great. And I will say having the volumes mount was pretty awesome in this use case in that I'm able to share my storage solution that I'm using on the Dagster side and the Modal side. And we're using the same environment variables in both our Dagster project and our Modal project. So it's the access is the same.
Yeah. And you end up with something that like looks and feels like a file system, which is not just important for like your own like sanity and not having to think about a non-POSIX like storage system, but also like your code. Like you don't have to even do something like, I used to do like from smart open import open, so that you could like pretend that S3 buckets were actually just files. And this has that like kind of incorporated into it.
Nice. So now we're actually going to just open up the code and explore it and kind of talk through some design decisions. And I'm going to ask Charles questions about the modal implementation. He'll ask me questions about the Dagster side of things. If you guys have any questions, I actually really encourage you to ask them while we're exploring the code base. But this will be a little bit less formal than like our slide deck, and we'll just be looking through the code and trying to learn some stuff together. So I'm going to switch over to here. How does that look, Charles?
Maybe zoom in a bit.
Okay.
One more time.
Better?
Yeah, I like that. Anybody else think it needs to be bigger?
Yeah, just let me know.
Speak now or forever hold your peace.
Cool. Yeah, so this is the Dagster Modal demo project that I've cloned on my local machine. We kind of showed this structure earlier, but we have our Dagster Modal demo, we have our Modal project, and if we look inside of that Modal project, we have that transcribe function, script that I mentioned before. We also have some other little ones in here that I didn't mention, just like a hello world to using Dagster and Modal together. We have this config.py file with like all the configuration that we need for our transcription. If we look at the Dagster Modal demo directory, that's where our Dagster project resides. So the main entry point to our Dagster project is this definitions file. And we'll start by exploring there, and then we'll dig into other things. But we also have that pipeline factory file that'll be really important to go into. That one's pretty heavy. It has all of the assets, the sensor, everything. We have a bunch of utility functions, and then some shared resources and constants. So I'll start by just digging into this definitions file. we have this doc string at the very top. So I mentioned that you have to have some environment variables set to run this project. We have like our Cloudflare related environment variables, like the API key, the access key ID, the secret access key. We also need our OpenAI key to get that final summary. And then we need some details to send that email. So we're using, oh, I don't remember the name of the library, but we're essentially sending the email with Gmail. If you go into your Gmail account, you can go to the settings, you can create an application password, and that's how we authenticate with the Gmail server. I didn't want to set up like an SMTP mail server through in a Docker container. I was like, you know what, I'll just use Gmail for this. And then
Yeah,
finally,
and nowadays, if you try and set up your own SMTP server, you will be like shadow banned. No emails will be delivered. Yeah,
yeah, it's not easy.
yeah.
Yeah, and then there's also an environment variable here for like the recipient. Right now, you can just send the summaries to one person. You can imagine this being more scalable and making it more robust. But for this like proof of concept, it just sends the summary to one person. Um, so what else is going on in here? So we have this list of podcast feeds, and these are actually data classes. So this was just a little like configuration object that we defined so that you can like define the metadata for the podcast that you want to generate a pipeline for. So we have this RSS feed definition. You can provide a name, a URL, and like the max backfill size. Charles, earlier you asked like, would you get like 100 podcasts? Right now I have that backfill size set to 1. So the answer is no, you'd get 1 podcast. Um, but moving forward, every time there's a new podcast, you would get one. So you can see we have 3 podcast feeds here. We have our practical AI to stay up to date on things. We have Comedy Bang Bang so that we can relax and be entertained. And we're also summarizing the new Talk to a podcast that everybody is raving about. But we would rather listen to the or read the summary than listen to it. Then we call our RSS pipeline factory. And this is that factory method that I was referring to earlier, where each pipeline will have its own sensor and set of assets. And this function will return a Dagster definitions object. So you might be familiar with definitions where you can register your resources and your assets and your sensors and things like that. This project does a little bit more of an advanced thing where we have multiple definitions and then we merge them together. So and this is a really great way to like reuse your definitions or like separate your concerns and like kind of compartmentalize your project. So we'll have a separate definitions object for each podcast feed, and then we merge that down here and include those shared resources. So we have our Modal resource, OpenAI resource, and our S3 resource. And this is the entry point to our Dagster project. So this is how Dagster will know everything that it needs to like render and instantiate when you launch your Dagster instance.
Nice. Yeah, let's maybe dive into the modal resource.
Sure, yeah. So if I go here, you can see this is actually at the very bottom, you can see the file that I'm currently in. So it's Dagster modal demo/resources. And you can see I defined this modal resource that instantiates a modal client. And this is that custom Dagster modal pipes client that I was referring to. So here you can see it just takes in a project directory and then an environment variable, but we're not using that in this case. So we're just passing in this project directory that gets the path of this current file that we're in. So this resources.py, and then we go .parent, and that goes up 2 directories, and that will be like where our modal project resides.
Nice. Yeah. A tiny aside, but the like path dunder file like blew my mind when I first saw it. Like just I remember lots of times like really struggling with managing like relative files and like, oh, what do I do? Do I make it absolute? Like and the nice thing about this pattern is you just express the relative position of 2 files very cleanly. And I like now this is like how I do every path in Python. I do path under file first.
Nice. Yeah, it's super powerful and flexible. Yeah, so we have our like modal resource here. We're not going to dig into the OpenAI one or the S3 one, but this one's coming from the Dagster OpenAI integration, and you just give it your API key, and then it gives you an OpenAI client. The S3 resource You give it the in this case, you have to give it the endpoint URL. That's something specific to Cloudflare. But then you give it your access key ID, your secret access key, and this gives you like an S3 client that you can then use throughout your assets. And just so you know, Charles, in Dagster, we have this concept of resources that are like reusable throughout all your assets in your project. So if you ever need to use S3, you just define it once as this resource, and then you get access to it as a function parameter of your asset. So it gets like injected with that decorator.
Yeah, kind of like like dependency injection, or like in PyTest where you can like inject,
Oh yeah, like
what's the term for
fixtures.
that? Fixtures. There we go.
Yeah,
Thank you.
yeah, exactly. Yeah, I think maybe we can look at the modal client really quick. So this
Yeah.
is actually um, in this Dagster modal folder. This one might actually get folded into the Dagster mono repo at some point to be an official Dagster modal integration. I think that would be great. But this
Yeah.
is how you would implement a pipes client. So right here, all we're doing is we're inheriting from this pipes subprocess client, and then we're defining some methods on it. So we have this deploy method. We don't use that in this demo, but it's essentially wrapping the modal deploy command if you want to deploy a function to persist in modal. And then we also have this run method. And this is the one that we make heavy use of, where you can call modal run, and then you get, you can pass in this function reference. And then it also gets access to things like the context, some extra parameters, the environment variables. All of that will be available to you in your subprocess where you're running modal.
Nice. Yeah, I guess the only thing I would say about the deploy part, since we aren't going to talk about it that much, is like, yeah, in this example, we're doing run because this is very much like a pipeline, or a like, yeah, a regularly triggered job. And in that case, you have modal run that's kind of like executing a script, right? Modal deploy is for like creating a little service. So like you could create you might, let's say you are using a local like self-hosted language model in a lot of your like Dagster pipelines, and then you might be like redefining it over and over again. You'd pull that out and set up a deployment process that runs on Dagster to create that service, and then like talk to that service the way you talk to S3 or OpenAI's API or whatever from your other Dagster pipeline. So Modal is also sort of like with deploy set up for defining basically like Python microservices without, the agonizing pain.
Yeah, you could imagine like for this pipeline, if we were to create a little website to go along with it, you could you possibly like have it generate the like transcriptions and then like host those somewhere and run that as a deploy? Is that something?
Yeah, exactly. So that's what I did with the like pet art generator, is like a deployed Python front end and back end. And yeah, the modal deploy is great for that. So like API services, or actually you can even just like make a function that can be callable elsewhere. So you can just take a Python function, modal deploy it. You have a Dagster pipeline behind that so that you make sure it's nice and robust. And then you can just like look that function up by name from any other Python client. So that could be like
Mm.
inside of your Dagster, your other Dagster pipelines. You just do like modal.function.lookup, like podcast transcriber, and now you can just like run it on or like the Whisper model or the email sending like piece. You can kind of like have those deployed and re-executable
Nice.
as like, and they like kind of look and feel like normal Python functions.
Nice. Yeah, that's really cool. So let's take a step back, and I think what we'll want to do is we'll go through the like pipeline factory so you can see how our assets are defined, but I really want to also go through the modal code itself so you
Yeah.
can talk about kind of like that scalability, how you have like the remote aspect and the local aspect of it. But for now, let's go into this pipeline factory. And just a forewarning, there is a decent amount of code here, but it's kind of just like chunked up into separate assets. So as you can see, just looking at the function signature, it takes in that data class that we defined. So that like feed definition, it returns a Dagster definition that we then merge in like our entry point, like that definitions.py script. And here we start off by defining the partition definition. So as you know, these assets are partitioned by the podcast episode. And this is something that changes. It's not static. We don't have like the same podcast episode forever. A new one's releasing all the time. So we have this concept of dynamic partitions, which just means like the values can continually change. You can add more partitions to it over time. And we pass in this partition definition to each of our assets. So if I go down here, we have our first asset here called podcast audio. We're constructing a name so that the assets have different names for each podcast. So just using an F string here, we're saying this asset name will be the name of the podcast feed underscore audio. And we give it that partition definition. And this one is just a Python asset. And you can see here, we start off by using this asset execution context. This is also something that gets injected into our asset definition along with like a configuration object and our S3 resource. And we start by saying, taking that partition key that is on this asset, get me like the audio key, like the path that I want to like store this audio file in R2 or S3. So that's how we're using this partition key to kind of map it to the files that we want to use. So like the transcription file, the audio file, all those things, that they are derived from this partition key. So that gives us like this shared thing that can be used. And then we have this check in here so that like if the audio file already exists, we're not going to bother with downloading it again and re-uploading it. It's not necessary to have this, but I thought it was nice just like as I'm developing, if I like wipe out my project and rerun it, like the file still exists there. We don't need to run it again. So we add some metadata to our asset saying, oh, it was cached. This file was already there and it was at this key. Otherwise, we upload that object using our S3 client. We set the status in this metadata as uploaded. And we also include like the size of the file. And then finally, in this asset, we just materialize the result and pass in that metadata. So then when this runs and in the Dagster UI, you'll be able to see like, oh, it was an MP3 file of this size, or it was an MP3 file that was already cached. It was already in our S3 bucket. So that's how we're downloading the audio files. We have this download bytes util function that's essentially just getting the entry from the RSS feed and then getting the bytes and then uploading it to S3. Cool. Next up, we have the transcription. And this is the really cool one, in my opinion, because this is where we're leveraging Modal. So again, we're passing in that partitions definition. This asset actually depends on the previous asset. So the way you do that in Dagster is you give this deps argument, and you can give it a list of dependencies. And we're saying, yeah, I want this transcription depend on having the audio from the previous asset. And we specify the compute kind as being modal. That's how you get that nice little icon in the UI. And then we kind of do a very similar thing where we take that partition key, we get the destination of the audio file, and then for our transcription, we're just going to take that same path and replace .mp3 with .json. There's maybe more robust ways to do this, but this was simple enough. We check if that transcription exists. So just like we were doing with audio file, we're not going to retranscribe things if it's already present. And if it doesn't, that's when we call out to Modal. So this is like where the magic really happens. So we rely on having certain environment variables in our Modal subprocess, like these Cloudflare access keys. So we kind of just create a subset of that, like as an environment variable dictionary, and we pass that in to our modal.run call. So we say the function ref is this modal project.transcribe that corresponds to that transcribe file in our modal project. And then we say, I want to pass in this extra parameter of this audio key. And this is what we leverage on the modal side of things from the Dagster context to get like the MP3 file and then transcribe it. Any questions here before I keep going?
No, this looks good. I guess maybe it'd be good to maybe quickly comment on secrets management. Because I think like, yeah, both Dagster and Modal have a notion of secrets. And it was probably the case that you could write some little shim to integrate those if you didn't want to do it via this environment passing method, right?
Yeah, that's right. Yeah. So right here, we just have this .env file in our repo that has all of these secrets. In the one on GitHub, we have this .env.example, so you can see like the structure it would be. But you can also manage these secrets on Dagster itself, or sorry, on Modal itself.
Hmm.
Or you could use a secrets manager like AWS Secrets Manager and access them that way. Um, for convenience, we used environment variables here. But for like production grade, like a tool that's being used by a ton of people, you may want to consider like proper secret solutions.
.env is a proper secret solution, if you ask me. But
I mean, we use it a lot. Like you can also set the environment variables on your like Dagster cloud instance. So we're still super heavy on using environment variables.
yeah, it's a good pattern. Yeah, let's check out transcribe then.
Yeah, let's go into it. Yeah, so we won't go into these just yet unless we have time, but it's like the same thing. We're like we're getting the keys, we're like using the OpenAI client to summarize it, and then we're getting that summary, and then we're using this YAGMail library to send an email. That's like the TLDR of the pipeline. We can also talk about the sensor in a little bit, but instead let's talk about like what we're running on the modal side of things. So if I go to transcribe.py in this modal project. At the top, we have this um, uh, doc string here where it tells you like you can if you just want to run this without Dagster, you can just call modal run modal project.transcribe. Um, but otherwise, if you're running this from Dagster, you can access like this Dagster pipes context here. So it all starts with like this local entry point. And let me know, Charles, where you want me to move around in the file or what you want to talk to.
Yeah, maybe. Yeah, let's. The kind of neat thing about Modal is your Python code gets the global scope Python code gets run twice. Once locally to like kind of define your application, like define the functions that are involved, and then if it's like whatever function you were calling, or down here when you call .remote, we rerun the code in the global scope to set up that Python function, and then we execute it. So that's kind of like so if you jump up to the top here of this file, like all of this stuff gets run like twice. Like we don't go inside any of those functions, but we like get their type signatures and definitions. Like the app image definition is available locally and remotely. So like that decision is to make sure that like you have control over that, or you can see a bunch of this stuff locally. Um, and like that the environment is kept as similar as possible between like what you have in your local environment and what you might like inspect in a REPL and what's on Modal. Then what like when you do Modal run, what happens is like we run everything in the global scope, and then we look for a local entry point like the at the bottom of the file that Colton was showing. If we could jump down. Um, yeah. So then this is sort of like your if name equals main, but for modal scripts, for scripts where you have components that run on modal. And so now we like everything has been defined. So then we go in and we do the transcribe episode dot remote on line 252. Um, that there, we like a modal function has been like defined, configured, and then when you call it with dot remote, it'll be like spun up and like if any like if there are new replicas created, if you call it many times, then we'll like scale it out. It looks like in this case, actually, if we could go back down to where you called transcribe episode, in this case, yeah, you are just calling on a single episode, and Dagster would be managing via partitions,
Hmm.
like all the episodes, right? So let's maybe then in transcribe
Yeah,
episode.
this is where it really fans out. Where so like we're chunking things into segments, and then you call this. I think star map might
Yeah,
be the
yeah.
the, the thing.
Yeah, so you can call a function just once with .remote, or you can map it over a Python iterator and get back like an iterator over results with .map and .star map. And by the way, all this stuff is like compatible with async Python with .aio methods, or you can just like async for like all that. We have like an extra little wrapper library that makes sure that things can be run either sync or async. But yeah, so that gives you this like nice like way to express, yeah, this is something that happens in parallel. And yeah, I kind of already expressed this before, but just to like pin it here, it's like Modal is great for this like embarrassingly parallel stuff. Like each segment doesn't need to communicate with each other. Each episode wouldn't need to communicate with each other. You just need to like you just need to run the same block of code with different inputs, and that's what this achieves. So .star map is like so that you can send in like keyword arguments. Um, if you wanted, actually, I think you might have been able to write this with just map because you're only going over one iterator here,
Mm.
and star map is for multiple iterate. Live coding it would be a bad idea, but yeah, but there's sort of one version that's just like a single iterator, and then and another one for like multiple iterators to map onto like keyword arguments.
Nice. Yeah, I know we're starting to run low on time here, but
Yeah.
just wanted to like kind of reiterate. So like, modal is
Could
what's. Oh yeah.
could we maybe modal run this file just to like see it in the
Right now, that's not possible because we're leveraging the Dagster context, but that's something that we can make this a little bit more robust moving
got it.
forward, and
Yeah,
that's
yeah.
yeah a to do. Yeah, so like right now, like we're injecting that like context in this like entry point, and that's how we get the audio file path, and then we call these remote functions through Modal, and as Charles said, like we then make it massively parallel by like cutting it into segments, and then we like transcribe each segment.
Yep.
Um, just wanted to call out that like we use this same cloud mount bucket on each cloud bucket mount on each function, and you can like specify things like the number of CPUs, the timeout, the image you're using on each function itself.
Yeah.
Um,
So then yeah, if you have a like the transcribe segment one like needs more resources, it might need a GPU if you had some like beefier model to run on the segments. And so but you don't need a GPU on the transcribe episode function because that's just like a coordinator. Um, so you can have like independently scaling components, which is nice. Like especially if you're like putting together a complex pipeline on something like Dagster, the components are going to have distinct hardware requirements and distinct scaling needs, and all that. All the like Modal will handle automatically scaling all of that stuff for you. So I think by default in the free tier, this would top out at I think 100 replicas for the transcribe segment. You can control that if you want. You could set a lower limit. But then I think, yeah, in the paid versions of Modal, that goes up to thousands or tens of thousands of replicas. So you could really rip through some podcasts.
Nice. Yeah, it's super powerful. I guess just one other call out here before we go back and start to wrap this up. I really encourage you guys to dig into this code. It's super exciting. I really enjoyed like collaborating on this. But you may have noticed also like we have imports inside of these functions themselves, and that's because like the Whisper library isn't we didn't install it on our host machine. It's just installed in this image that is accessible, and it becomes accessible to us like when we run this remotely. So that's just a quick call out as to why it was written this way, if you're curious.
Right. Yeah. That is a funky feature of Modal, but it's part of the like run the global scope locally and remotely. So anything in that you import in the global scope needs to be in both places. So you could install this stuff locally and then also have it on Modal if you wanted to like do some FFmpeg stuff yourself and then like communicate back and forth. But yeah, I think with Dagster, the cleanest thing would be to have a super simple local Python client and then like put everything else onto the Modal side like
Yeah.
this.
Cool. Yeah. So we won't go into the full code just due to time constraints. Um, but the full like pipeline factory can be seen here. I think a really interesting thing to look at if you're curious is how like this E tag works with the sensor and how we query for podcasts and then trigger like these run requests for each podcast. We won't go into the weeds on that right now, but at a high level, we demonstrated how you can orchestrate Modal from Dagster using a pipes client. We showed you how you can create like this pipeline factory so that you can kind of like define this function once that can produce a pipeline, and then you can kind of parameterize it and add new pipelines more easily. You could imagine this being like a YAML file also if you wanted to just like have like a high level DSL on generating pipelines. And we really kind of just showcased how nice it is to use two tools that kind of had like developer experience in mind, both Dagster and Modal.
Cool. Yeah, let's hop back to the slides so we can
Yeah, sounds good.
close out.
Let me switch over here. Nice. Can you see that?
Yeah, yeah. I think we answered questions as we were going, so maybe just our last slide. Yeah.
Yeah. So call to action, next steps. We really encourage you to hop on the Dagster Slack. We'll actually be in the deep dives channel of the Dagster Slack to answer any more questions if they come up. And also, if you want to try out Dagster Cloud, that'd be great. We demonstrated here running it just locally, like using the Dagster dev command, but Dagster Cloud makes it a lot easier to get that like production ready data platform running.
Yeah. And if you want to check out Modal, head to modal.com. All you need is a GitHub account to sign up for the free tier of Modal, which is enough to run that example. You get $30 a month of free compute because it's serverless. That's actually, you can run quite a bit off of that. So like I had a bunch of like little fast API servers and little tiny ML endpoints running off of that. So it's a great way to like just try it out, see if you think it's a good idea. If you have questions, we also have a Slack. So there's like, yeah, we pride ourselves on the extent of support that we put in that Slack. So please come through if you want to ask any questions about Modal.
Nice. Yeah, and just as a final reminder, the code for this is all available on GitHub at dagster.io/Dagster Modal demo.